Hi guys, welcome as we do the question before us. And I read the question. A function of x is defined by fx equals to x minus x squared between negative pi and pi, and the period is 2 pi. Determine the Fourier series and deduce that. Guys, you deduce that when x is equals to 0. So we start off, guys, to do the question. And the first thing, guys, is that we should plot the graph. And how do we plot the graph? Is when we come and fix x, and then we determine f x, which is x minus x squared. And these are the figures, guys, I was able to find. And in plotting the graph, this is the graph I did come up with. The figures are here. You can check them. And the graph is right here. Guys, as you can see, the graph is neither odd or even. Or we could say, because along the y-axis, the symmetry, it is even. Along the x equals to y is supposed to be odd. And as you can see, it is neither of them. And so guys, now we continue to do the question. Guys, now we use this equation before us. And this is the Fourier series equation. What we are going to determine is A0, AN, and BN. For A0, the equation we have is as stated. That is 1 over pi, integral from negative pi to pi, x minus x squared dx. Guys, we need to integrate this, and this is how I have integrated that. As you can see, this is x squared all over 2, x cubed all over 3 when you integrate. And then now guys, you fix your pi and your negative pi. When you do that, guys, it is done like that. You can, to save on time, guys, I'll give you time and you will look at that later. But as of now, let me just go ahead because I believe that you know how to fix negative pi. That is here, if you have negative pi and pi, you just fix them here. So when you fix them, guys, finally our AN is going to be negative 2 pi squared all over 3. This is just integration, and I can leave you to do that. But your answer should come to negative 2 pi squared all over 3. Guys, we have the AN now. For AN, I had given an earlier video, guys, and we were able to look at it. And our answer was actually negative 4 all over n squared minus 1n. Guys, you use this equation for AN, and this was our answer. So AN, guys, comes to that. And so we should note this. We should note the A0, AN, and now I now show you the BN. So guys, for the Bn, this is the equation we have. 1 over pi integral from negative pi to pi, x minus x squared sine nx dx. Guys, we integrate that by use of integration by parts. And so we call this one u, this we call dv. According to the equation here, guys, we come and differentiate u. We get 1 minus 2x dx. You integrate dv, and this is what you get. And so, guys, now we come and fix in our equation. That is for u. U and dv is what we had originally at this point. So we are not concerned with u and dv. We are going to u and v. So for u and v is what we write here. U, this is u. And here we have v. Minus v du. Because this has a minus, this now becomes a plus. Guys, this is du. As we have it here, du. and this is v. That is cos nx n dx. Of course, this dx is brought here at the end. So guys, when we do that, we now are left now to integrate this because we have completed with this. Now we integrate this. And that's why now we have also chosen again to have u and to have a dv here. So we integrate this part. Integrating that part, guys, we do the same we have done. For u, we have 1 minus 2x du is equals to 2 negative 2 dx, and the dv, we have that, v is that. Using the same equation, guys, we now come and form this equation. And this, the first one we had already done, and the second one we are doing, this one is supposed to be u here. This is supposed to be v. Now minus integral of du. This is now du. And so we have the du here. And because of the negative here, guys, I have changed. This one is now supposed to be plus. Remember, in our original equation, we usually have minus integral du and v. And so, guys, I have changed that to be plus because of the negative that was here. And then, guys, we have sine nx all over n squared, which is represented by v. And the dx is from this point. And so, guys, from there, we come now and have our bn here, as you can see. This now becomes our bn, and now we are ready to replace with negative pi and pi. And this is cancelled because, as you said, sine nx will give us 0. That is sine of 0 of 180 is 0, of 360 is 0. As you put n 1, 2, and 3, you find that it's always 0. And so, guys, we now fix our limits, the lower limits and the upper limit. But before we do that, we also integrate this. And this one gives us 2 cos nx all over n cubed. And this one now becomes a negative. So from there, guys, we now continue. And this is where now we are. We are at this point, whereby, guys, now we come and for this negative and negative, we can put it here. So that now we have this becomes plus and this becomes plus. Then, guys, now we can put our figures. That is our limits, negative pi and also pi. We begin with the pi. I have already put pi here and pi right here. Now minus, I put now negative pi. When it comes to cos, negative pi is the same as pi. That is, as we can say, cos 180 is equals to cos negative 180. And so pi in cos will remain pi. Then I put negative pi there, squared, plus 2 cos pi n all over n cubed. And after factoring out cos pi n all over n, and here negative 1, this is what we are left behind with. And this now comes to, we'll be left with 2 pi. And the 2 pi is right here. And after we cancel, we can do some cancellation here. So guys, before we come to cancelling, we have left out, that is the pi right here as a denominator. And so this pi will also be at this point. We have pi, and therefore we shall have even pi at this point. And so this is the pi now that is going to cancel. And now we are left with negative 2 over n, which is this negative, and 2 cos n pi. Guys, now here we have cos n pi can be represented by that. And this is now negative 2 all over n, negative 1 raised to n. and that is our now Bn. So guys, we are able to identify our Bn. We already have the An and A0. So our A0, guys, was negative 2/3 pi squared all over 3. And that's what we have fixed there. And now we come and fix the An. For the An, we had negative 4 multiplied by negative 1 raised to n all over n squared. And this is what now we are going to do. We are going to say 4 all over n, let's say n is equals to 1, so it will be 1 squared, because nx, and now n is 1, so it will be x. We go to the next. The next, when n is 2, the 1 is going to be positive. And so we are going to have negative 4 here. All over 2 squared equals 2x. And then for the next, the n here, 1 raised to 3 will negative 1 raised to 3 will give us negative, and negative gives us positive now, and 3 squared. Now this one is negative, so you have plus, negative, and so on. And then we now come to Bn. For the Bn, it's right here now we put negative 2, negative 1 raised to n all over n. Starting with 1, we shall have 2 all over 1 sine x. Remember here we have 1. Now minus 2 all over 2. And this one, when you say 2, this one becomes negative. And this one we have 2. We have 2 only there, sine 2x, like that. So guys, this is our series. Of course, it's continuous. And then we are deducing this. For us to deduce this, we say x is equals to 0. And so we looking at our graph, at x equals to 0, the fx is also 0. So here is the graph, x equals to 0, fx is also 0 at that point. And that's what I mean. And so when we put that, guys, we shall be putting the first case for cosine. We now put cos as 0. So when you put cos as 0, all these are going to be 1. So this is now going to be 1. These are going to be 1s. The signs will not change. But when you do that to sine, they are going to be zeros. So all that will be lost. And we shall be left with this. This is what is going to be left. This is lost. And so we can bring this negative pi over 2 on this side. So when you bring it on this side, guys, now we can now divide by 4 there, comes 12. And this is actually pi squared, even as you can see right here. And finally, this is what we get. So guys, thank you for listening to me. Bye.